Hello and welcome to ESAPOD. I'm Paul Nielsen. We're reporting today from the Space Transfer stand at the Hanover Fair in Germany, where 10 companies are presenting their spin-offs from space technology developments. ESA's Technology Transfer Program and its network of technology transfer brokers have successfully transferred hundreds of technologies originally developed for European space missions to non-space applications. We spoke to some of the startup companies who provide services in non-space fields based upon space technologies. They have received support from ESA's business incubator in ESTEC, and this has helped them to get their business started.
Miramap is a data service provider of Earth observation data. We use actually two things from space. One is autonomous navigation. This helicopter flies fully automatic, like satellite, and we also use spaceborne scanners like soil moisture scanners from satellites. One example is the SMOS satellite, soil moisture and ocean salinity, and we made it smaller and operate from these platforms. We use for a wide variety of applications. One of them is dike monitoring, water seepage, but also for inspection of industrial sites like chimneys, or monitoring of highways and water flows. The incubator greatly helped on the success of our company. We started there, we got full support there, access to the facility, and full support for 2 years, and that's how we got started.
NVSAT, for instance, has 25,000 parameters to be monitored. This figure is very close from what an oil and gas operator has to look at into a control room from The Hague, monitoring its operations in the North Sea. So both systems have the same amount of parameters. They are both remote. The oil and gas industry has decided to unman its platform progressively, and we are now dealing with a similar type of requirements. We're capturing the focus of the operator for not more than 10 seconds, offering him a visual summary of what is happening. So by introducing this new summary, we lead the operator faster to his point of focus by clusterizing the alarm graphically on this new system, RevOps. We are now in our second year of incubation, at the end of the R&D phase, so just turning into production.
And what sort of support have you received by being at the ESTEC Business Incubator?
First, the help of the operators, defining the requirements of the user graphical interface. We didn't want to develop a product which had a mismatch between our perception of what they needed and what they really wanted to use, they were willing to use in the control room. We currently have 2 pilots built in, monitoring 4 offshore platforms.
The German company S-Cube presented another successful transfer. S-Cube has developed a very small sensor to measure oxygen levels for re-entry space vehicles. This sensor is now used in home burners to control the exhaust and in measurement masks for athletes.
S-Cube is developing gas sensors based on solid-state electrolysis. For example, commercially available sensors are lambda probes that are used in cars for combustion control. But these sensors are not really good for space because they are quite big, heavy, and need a lot of heating power. So that's why we wanted to miniaturize the sensors, and that was done especially for measuring re-entry conditions, so measuring oxygen in high altitudes and during the complete re-entry. Having this miniaturization, it's very easy to find a lot of terrestrial applications. So the very small sensors are reacting very fast, and that was one example for measuring oxygen in ambient conditions on Earth for human breath measurements. And also together with carbon dioxide, we can measure now with our sensors oxygen, carbon dioxide and flow directly in a human breath.
Another application you're saying is for fueling systems, testing the exhaust gases from heaters.
Yes, so that's why we have a sensor that is very well reacting on combustible gases. And if you place the sensor in the exhaust gases, you can control the heater to an optimum point. So there's a special algorithm that we use with our sensors, using the signal to recalibrate the settings of the system, always operating at the optimum point and reducing exhaust gases that are bad for the environment.
And also you save money.
Yes, it's about a saving of 10 to 15% of fuel if you really work at the optimum point.
GTS means Global Transmission Services, and it's a completely new time signal. That means that you take a flight from Paris to New York and that you don't have to adjust your watch. The GTS antenna sits behind this solar panel. GTS also provides data, means that it's not only receive data, but send data. So in remote areas where no communication is possible, you can communicate via your watch.
So we center here on spin-off from developments that the European Space Agency has supported, and that's directly here a spin-off from the material science laboratory of the International Space Station, where we have developed monitoring techniques that we are now using together with the European air industry to make airplanes feeling. They should tell us when they have some problems, when they should be repaired, before they fall down, and we are using ultrasound that the structure itself tells us what the load is, how much you bend these wings, how often you do it, and if tiny cracks develop.
For ESAPOD, I'm Paul Nielsen reporting from the Space Transfer 08 event at the Hanover Fair. For more information, please visit www.esa.int. Thank you for watching.